So I'm going to talk about near real-time AI deployment with huge data and at super low latency. I was looking about this talk, I was looking to see whether I could find a joke about data science. So I Googled jokes about data science and I couldn't really find any which were really funny. But I did find on Quora someone asking a question that I'm going to go on a date with a data scientist. How should I prepare? And the suggestion was maybe sign up for an open source project and ask her whether she wants to join. What I would recommend is that he shouldn't talk about how big his data is. But it is important because the size of data actually matters, as we will see in this talk. So with that, that fell flat, right? Okay. So with that, I just want to talk about, I'm Levi Brackman, Principal Data Scientist at Travelport. We have a team of data scientists working on productionalizing machine learning models. And what Travelport is, we're a travel commerce platform. So the way I'll describe it is so many of the companies that you use, or maybe how you booked your ticket to come here if you flew here, probably somehow came through Travelport. So a lot of the well-known online travel agencies will use us as their backend to do search for travel, etc. So you might not have heard of us, but you've definitely heard of most of our customers. So some of the challenges which we faced when we wanted to build machine learning models was, first of all, that models we found, we built them and they were very accurate. For the first hour, they were pretty accurate, or very accurate. The second hour, pretty accurate. Third, fourth hour, and eventually 10, 15 hours later, the models had already decayed. The second issue we had was the volumes of training data. So the huge amount of data which comes in and which is generated on our platform. You're talking about, just for one use case, you're talking about 40, 50, sometimes 70 gigabytes an hour of data which needs to be trained on. And then you had this time series issue, which is that, if you've ever booked a ticket, you're probably very painfully aware of the fact that if you don't book it right now and you wait a little bit as it gets close to departure, the price might go up. So this is something which fluctuates. It's really a time series thing. So you want to make sure that you book it at a time when it's the cheapest. But because of this time series issue, all the ingredients which goes into actually finding that price and the best tickets, that changes also. So if you're building predictions, the prediction you might get now might be different than the one you might get in 5 minutes' time, and therefore you actually need to be scoring these models in real time. And we had to figure out, well, what compute do we need to do this training? We weren't sure at the very beginning what it was. And then part of the issue also was that we want to, as the previous speaker spoke about, we want to be able to return searches back to the customer really quickly, preferably under 1 second, so therefore you can't have that your scoring of your models take 50 milliseconds. They actually have to happen in microseconds. One of the benefits of H2O is that it's really, really fast in scoring. And then we had the whole DevOps issue, right? So it sounds like at Booking.com, they're doing everything on premises. We're kind of really open to the cloud. So we want a hybrid between the cloud solution, a solution which kind of can be a hybrid between the cloud and on-premises, and we did that. Do we want it real-time or batch? As a matter of fact, since the model decays and the second the data kind of starts to be old, it's old. So if you do it in batch and you wait for an hour for the data to accumulate, that could be problematic. Therefore, what we wanted to do was having a streaming solution. We need the scoring mechanism, and the question was, well, how are we going to deliver the models? Are they going to be APIs, or are they going to be some kind of function within an application? So a lot of people, the way they're using scoring nowadays is, they're building an API and it has to be a network call to the API to score your model. Well, that network call, if you've got just 1 second to get back your transaction to the customer, that network call is actually time. Doesn't matter if it's milliseconds. Every millisecond counts, so it's time. And therefore, maybe you want to do it in a better way. Maybe you just want to deploy it on the actual box as a function call to your application. So we had that challenge too. So this is talking about real-time machine learning and near real-time scoring of the model. One of the things which is important to talk about is kind of the talent you need to be able to build something like this. It's not just data scientists. Now, data scientists are really, really important. I don't want to kind of understate how important they are. But there are a lot of other things which are also really needed in this. So you need big data engineers and software engineering in order to be able to create, especially if you build this in the beginning and you don't realize that this needs to scale. So if you're talking about, how many TPS you're doing, thousands of TPS, hundreds of thousands of TPS transactions per second, potentially, that really needs to scale. And, there's building software that scales is actually a very challenging thing, especially when you need this really, really fast response time. So you need really talented software engineers. You need to kind of keep this in mind up front. And then the other thing is, which people kind of overlook sometimes, is that if you're going to deploy this on applications, then the application needs to be able to speak with each other, right? So you need to, if you've got a C# application, you're going to need some kind of code which is written in C#, or else you're going to be running Java on your C# box. Could be, a little bit more challenging. You better to have a C# kind of mojo rather than a Java mojo. Well, if you're going to have that, then you're also going to want to make sure that your data scientists can talk to the owners of that application as well. And that the people who are, if you're going to work with the application, you need the kind of this cross-pollination between the people, the software developers of the application, and also, the data scientists. So a bunch of technology decisions which we had to make up front about what should we use. And this is where H2O comes in, and we've partnered with them. We are a customer, an enterprise customer of H2O, and we've had a good partnership with them, and some of the reasons why we use them and the benefits we get from H2O. So there's a lot of open source software out there for machine learning, but how many of them actually offer enterprise support? So if you're a big company, you actually need someone to call if there's a problem. If your data scientists built it and then they leave the company, there needs to be some continuity with regard to the software itself. And a lot of the open source products don't necessarily have easy enterprise support come with it from the company which made it. H2O does, and that's a big benefit for an enterprise. And also then the question is, how easy is it to deploy these models? Right? It's not always that easy. H2O was actually built, as the previous speaker spoke about, the mojos are actually built in a way which makes it really easy to actually, once you've trained the model, to then deploy it. I know other people have come on board to do that, but H2O was really, to my knowledge, like the first to make it really easy to actually deploy models into production. And then how fast it is to return. And we benchmarked this. H2O was the fastest into which to return the predictions. And that's really where it shines for us. If you're going to have to, like we have to, return these predictions really quickly, in microseconds, you need a kind of a inference engine which is going to be able to do that. And then some of the other things, how are you going to deploy it? If you're going to have on-prem or in the cloud, I believe one should be open to both. So as part of, when you're building this, one of the things you always need to keep in mind from the very beginning is that you're going to have to productionalize this. And to operationalize machine learning and then to automate the process. So I think, it sounds like this is something which a lot of companies have kind of solved, but not all companies. But to actually be able to take this machine learning pipeline, which is built in someone's VM in the cloud or on the cluster on premises, and then actually productionalize it to make sure that it works and automates, and your enterprise systems can actually solidly rely on it. This is actually a pretty big challenge, and it takes a while. So for example, things change in the data in the real world. And as they change, to be able to get accurate models, that also changes. A really nice feature of H2O is they have this, this grid search thing, which you can do, which helps you find the best hyperparameters for your model. But what we've done is we've actually automated that process so that actually we run grid search offline every so often, and that will automatically then update the hyperparameters in the model building. So that's the one thing which you would need to automate. The monitoring and the performance of the models, that's also something which you need, because if the models degrade, you need to know how to deal with that. And then sometimes you have to have your own success matrix for the model. So, there's H2O spits out a lot of matrix for the model, which you can kind of tap into and use in order to be able to figure out whether your model is performing correctly or not. But part of that is for the business. The business sometimes has other criteria which it needs in order to know whether the model is performing correctly or not. And so sometimes you're going to have to build your own kind of scorecard. So as the model comes in, the business doesn't necessarily want to, or the application which is using the model doesn't want to get a probability score. It wants to know yes or no. So how do you tell it yes or no out of the probability score? How do you know where the thresholds should be? So part of might need to build in this ability to kind of get the correct thresholds to be able to score the model correctly so the business gets a yes or no. And the way we've done it is, and this might be pretty typical out there, but you get a yes or a no or I don't know. So there's a little bit in between where we don't feel the model kind of can predict accurately enough. We don't trust the model. And therefore, the answer is the model doesn't know the answer to it. And therefore, do a third thing. Right? So these are some things which you have to kind of think about. If you're a data scientist just building machine learning models in the lab, you might never have to think about this. But when you want to productionalize it, and your customer is another software application, then you have to think about, well, how does that piece of software understand the outputs of the model? So one of the key things to kind of stress here is that there's a big difference between somebody who's winning a Kaggle competition, for example, and the data scientist who has to build a model to actually go into production. There are many other things the person has to take into consideration beyond just how accurate the model is. You can have a very, very accurate model which you've built in the lab, which is completely useless in production. And one of the good examples of that is the Netflix competition, for example, that the winners of that Netflix competition, those models never went into production in Netflix. So it's really important to kind of keep that into consideration, that productionalization at the end is really, really key. And whatever your data scientists are building, they have to be thinking about how that is productionalized. And along those lines, kind of the feature engineering is also really important, because some feature engineering actually takes time in the scoring process when you're doing inference. Feature engineering can actually take longer. If you've got quite a bit of computation to do in the feature engineering, that means more compute. It could be more costly. You need a bigger compute cluster in order to be able to kind of get those the scores from the model. Is it worth it? That extra bit of accuracy, is it really worth it compared to what the cost is going to be? So those are things, fancy feature engineering might be great, but it might not be practical in the enterprise. So there were a few other things which we kind of came across, and it seems like the previous speaker maybe came across a similar issue, is that, sparkling water is it works really, really well in the lab, but then with the size of data which we had, we found that the in-memory copy was costly, and therefore we actually separated these two things out as well, the H2O cluster from the Spark cluster. So we actually do our ETL in a Spark cluster, and then we send it to a separate cluster, which is the H2O cluster. And then the TPS, which we need for scoring. Again, if you're building this compute engine in order to score the models, you want to know how big that is. So yeah, it's true you could have just a compute engine, which is a set size. But if you're, as in a case of Travelport, the TPS goes up and goes down. For example, in January, you get the January jump, which is you get a massive influx of queries to our search engine in January. And then it goes down, March and April, it starts to go down. Then it again hits higher. So you need to have flexible compute. So you need to figure out what your TPS is what your transaction per second is going to be when you're actually scoring the model, so you understand what size of compute you're going to need. And then, again, what are you going to use? You're going to be RESTful API, or you're going to use something else? I want to talk a little bit about DevOps for data science, which is kind of a really important thing, because if you're in a software company, a technology company, then hopefully all your software engineers are going to have DevOps practices. DevOps practices are not that mature when it comes to data science. So we've actually built a lot of DevOps practices for data science. So we do, we use Jenkins for automated build and deploy. And so part of this is that the cloud, again, is something which is really helpful to be able to build this. And I would suggest that this integration that we've built, and I'll show you a picture of it before, of both a hybrid between cloud and on-prem is how we've built our pipelines. And from my perspective, it's very powerful because you get to leverage a lot of the new and greatest technology which is in the cloud, and you can then bring it to on-prem. And again, having H2O with the Mojo makes that really easy. Monitoring is also, of course, very, very important. So this is kind of a picture of what we've built. And as you can see, you've got our data center part, and then we use actually the Microsoft Azure cloud. And we're able to actually very easily transfer data from our on-prem, which comes in at a furious rate of knots, using Kafka into the cloud and into a Spark streaming cluster in the cloud. And you can actually buy instances in the cloud, which are not that much more expensive than what you would have to buy in your data center. And from that, you go to Spark streaming job. And from that, we've got our own H2O cluster, which we use to build the models. And then the end of the model building process, you have this mojo. And the mojos can then get sent very quickly back to on-prem for scoring. And then you have a compute engine which is able to use that mojo for real-time scoring. And what we have is we have two flavors of the mojos. One of them which is actually working, which is our Java API, which is a separate compute engine, which is called over an API, over a RESTful API. But what we're developing together with H2O right now is this C++ and with Mojo with a C# wrapper. So a lot of our applications are actually built in C#, and we would like to take that Mojo and place it on each box in the application. And we've partnered with H2O to kind of build a Mojo which has a C# wrapper, so we can deliver two flavors of Mojos, one in Java and one in C# for a C# application. But again, it works the same way. We'll send the data to the cloud. We'll do real-time streaming through Kafka and then Spark, and then near real-time training of models, and then deliver the models back on-prem for scoring. And we found this is a really good process to kind of get as close to real-time training of models and AI as possible. So this is just an overview, if you like, of our journey. Try to share some of the things which we've come across and decisions that we've made. I think other people who've gone on this journey in the last few years of trying to build enterprise-scale machine learning platforms may have, some things might sound familiar and some things might sound different. I'm happy to discuss this with anyone if they're interested in learning more about what we've done in our journey. But I'm glad to have been able to have the opportunity to come here today with H2O. They're great partners. And thank you for listening to my talk.
Any questions for Levi? Please add it to Slido. We have a few already on the screen.
So the first question, how do you manage your Spark and H2O sessions? So basically we use Jenkins to spin them up and spin them down. And one of the nice things, which is if you use the cloud, is this thing called infrastructure as code, which basically means that you can in a pipeline, spin up your clusters and spin up infrastructure as you like, and tear it down after it's done. Data message volumes. I think as they come in, there's 7,000 queries per second, which come in, and that spawns many, many, many more transactions within the system itself. Are you using plain Spark or Databricks? We use both. So there are certain things which we will actually use Databricks for, and certain things we'll just have our own Spark cluster for. You mentioned that when model is not sure, you don't use it. What techniques do you use to value prediction confidence for regression problems? That's a longer conversation, but we do an analysis on the fly to decide basically what the thresholds we need to use. And the business gives us their risk tolerance. And based on the business, and that will be configurable in the end, but based on the risk tolerance of the business for false positives and false negatives, that's how we make that decision. Yes, we're using Grafana and combination with, no, we're not using the other one, we're using Influx is what we use in order to be able to tell us the thresholds and then kind of give us an alerting system. Within the machine learning pipe that spans Azure and data center, where do you use, I don't know what GPUs is. GPUs. Oh, yes. So we have actually on-prem GPUs, as a matter of fact. Yeah, but we're actually currently we only use CPUs. We're not using GPUs currently. Data scientists get re-involved when we optimize the model. Right? We're constantly trying to optimize our models so we can get faster and use less compute. What monitoring solution do you have at Travelport? I should say Travelport. What monitoring solution? We've kind of built our own monitoring solutions. As I said, based on influx. Yes, of course we test new models before actual deployment. Yes. All right. Thank you, guys.
Great. Thank you, Levi. Thank you very much.